Welcome to a new video in our object-oriented programming module. In this video, we'll talk about encapsulation and abstraction. Now, last lecture, we discussed the concept of classes and objects, and today we'll start discussing some of the fundamental OOP concepts that are expected for you to know in order to efficiently practice object-oriented programming. Now, specifically, what we're going to focus on today is encapsulation and abstraction. And we'll also talk about the relationship between the two as we go. Right, start. Now, the first concept that I would like to talk about today is about the concept of encapsulation and information hiding. Now, the idea of information hiding, it really pertains to concealing the implementation details of a class attribute. What does that mean is, think about it when you define your class, you have attributes in that class, like, variables, and then you also have methods or functions. We call them member functions inside that class. Now, if you have your attributes being publicly accessible by anyone, then it's going to be quite hard to debug and trace what's going on. Because you're debugging and you're tracing, you have to debug lines of code. The attribute itself, it just has a value, but it gets assigned or changed with a different value or remanipulated outside the class, or potentially can be done outside the class if you have public modifiers for your attributes. So the idea of information hiding is let's conceal the implementation of a class attributes. Let's limit how you can change those values of class attributes. So the main goal of, and the main purpose of information hiding is this. It's protecting the internal state of an object from unintended or harmful modifications by external entities. If anyone can change your attribute in that object without being able to log it, debug it, then that's an issue. You're putting your code at high risk. However, if you're changing the values through specific functions, specific member functions, or methods, then in that case, you have the ability to insert log statements, do prints, maybe insert even control statements to add some conditions about which values are allowed for that kind of attribute and under what conditions you should assign or reassign the value for those attributes. And also information hiding. It focuses on securing the data within an object and deciding what should be hidden from and what should be exposed to the outside world. And we kind of talked about this and alluded to it last lecture when we talked about the access modifiers and access regions. Now, with information hiding, proper encapsulation can happen. And proper encapsulation through that information hiding will support effective class abstraction, and then it will enhance object-oriented design. And we'll talk about abstraction shortly. So think about encapsulation as some sort of an enabler for other object-oriented programming concepts. Now, let me tell you that object-oriented systems, they typically benefit from a lot more easier maintenance when they implement encapsulation information hiding. Now, think about it. If I know exactly where, these attribute values are being set, then I have a more secured code, so I have better security. Because I can add some logic that will prevent unauthorized users from setting those attributes and changing the internal state of the object. And I can also reduce the risk of errors because I have my attributes and the internal state of the object changing from controlled areas, which are the methods that are changing those methods. I'm sorry, those attributes. Now, when we talk about encapsulation um, and how you can implement it, there are really two main steps to do that. Number one is defining data members, your attributes. as private or protected, depending if you would like the children classes to have access to them. And this will ensure that data members cannot be accessed directly from outside the class. So that's practice number one. Practice number two is providing public methods to access and modify those private data. And this is typically done through what we call the getting and setting mechanism. It's a getter function and setter, a getter method and setter method that we will see how they can be implemented through the demo. Now, one thing I wanna think about it here. If you have a rectangle class, like a class that's pretty much called rectangle, now that rectangle will have height and width. You wanna for the height and width, you don't want these to be uh, um, negative values, right? Because technically, it can't be a negative. It can't be a like the height and width cannot be negative numbers. In that case, if I leave my attribute, publicly accessible, I can technically just access the object and assign a negative value to it, which would be an invalid state of the object in that case. But if I'm changing the values through setters, like a setter method that I will show you, I can pretty much just add an if statement at the top of it to make sure that, hey, the value that you're setting as the new height or the new width has to be a positive value. If it's not, maybe you can like log an error, print something on the screen, or prompt the user. So just keep that in mind. Now, how to implement this in Python and C++. So we talked about the C++ here for the private and protected. We have access to those. In in Python, to implement a private, then you need to proceed the method name with underscore underscore. The protected is really mostly like a naming convention. So you will just proceed your method name with underscore. But it has to be really, you have to track it yourself for protected methods. And we saw that in the demo last lecture. All right. Now let's switch gears here and talk about something else. I want you to think of a scenario where you're a project manager and you have a couple of members who are working on a specific task. One of them is building the front end, the graphical user interface, and the other person is working on the back end, building, what we call, APIs, application program, the application program interface, or pretty much like the methods that will extract data potentially from database or conduct heavy processing and then retrieve that response back to the front end. Now, if it's day one of development, I don't know what's coming, like we gotta have to start developing. If the front end person, in order for them to write the code, they need some sort of an idea about what type of data I should be sending to the backend, to the API, and what type of response I should expect from that API. So think about it. It's like a two, like pretty much, it's a two-part system here. You have this is your backend, and this is your front end. Okay. Now for your backend, you have here a layer. This is the API. So you have here like pretty much just publicly facing pieces. And the front end will have to like, create a request, receive like, let's say I would like to extract some data about user 123. Tell me their first name, their last name, when did they become members on our website? And then your backend will respond back with this kind of information. But in order for me to work on that day one, I need some sort of an idea about what is that API name, what's the data format that I need to pass into the backend function or a backend method or the backend API, and what is the kind of response that I'm going to receive. Now think about it, day one backend, the backend developer doesn't have any implementation yet and doesn't have anything to offer just yet. What you typically do in that case as a project manager is to have the team or have those two members construct what we call a contract. Now, the idea here of the contract is they will agree on, some basic information like, hey, this is the API name, this is the method name that I'm gonna be using. I'm going to agree on what is the parameter list, what is the input that you're going to send to the method name, and what is the output that you're gonna get. What is the response that you're gonna receive back on the front end? This is a contract. Now, a contract in that case to be any mechanism that would require a developer to comply with those specifications of a given API. And in that case, the front end developer will have to comply with those specifications, will have to make sure that they're calling this endpoint with the right type of information, with calling the appropriate name, and then they would expect the response to be in a certain format as well. So the backend will have to provide the output. The backend developer will have to provide the output in that specific format. So we created some sort of a contract. Everyone has to follow it, both on the front end and the back end. Now, typically, that contract that we just talked about, it really doesn't have any implementation. It's just something that we constructed so the team can work on it and can build the implementation. So it only shows non-implementation details like method name, number of parameters, the method return type, etc., etc. Now, these details are called typically rules. So I built some sort of rules by defining that contract that both the front-end developer and the back-end developer have to comply with. Now, in general, the concept of contract is usually to impose these kind of rules when communicating using APIs. And those contracts are some sort of abstraction. They're some form of abstraction because they really hide some unnecessary implementation details and they allow for flexibility in the implementation. Why? Because that backend developer really doesn't need to figure out on day one all the steps to implement, the functionality that's needed to be done in that method on that API. All they need to do, they need just to take that input or to know what's the input and what's the output, and I can figure out those internal details of how I'm gonna build it over the upcoming days. So technically, I built a contract without having any knowledge about the implementation details. So that's a very popular concept and very common when it comes to object-oriented and in general system-to-system communication. Because with contracts, you can have subsystems communicating with each other just based on these contracts. I know, hey, that there is an API and there is a method in that system that does one, two, three. So I'm gonna call that, and I don't know how it's gonna do it. It's gonna do some sort of black magic to me. It's a black box. I have no idea what it does. So it's gonna do some sort of a tricky magic, and then it's going to return back the response in the format that I'm expecting. Now, abstract classes, from an object-oriented programming standpoint, is used to, or is one way of implementing contracts when it comes to object-oriented programming. Now, abstract classes, they offer one way to implement the contract. They are mainly used to manage complexity. So when we see abstract classes, we're trying here to manage complexity. We're trying to allow designers to focus on essential qualities of the object rather than the specifics of how it's implemented. So, and it really involves creating like a very simple model that represents more complex underlying code and data. So you're just saying, hey, this is the very basic view of the contains the method signatures and it includes the parameter list, the input parameters, and the output. And it doesn't really tell you anything about the implementation. The implementation can be as complex as it is, as it can get to. So an abstract class is a class that contains one or more methods that do not have any implementation provided. So keep that in mind. That means in an abstract class, if I could have 5 methods, 2 of them are abstracted. They do not have an immediate or existing implementation. 3 of them, they actually have a concrete implementation. And now you may think, well, what is the point of that? Because sometimes as you go, you will get to learn more about, what functionality I can implement, what implementation details I can get, and the more you unleash, the more then you can implement. So just keep that in mind. It's a very important concept here. Now, abstract classes, they cannot be instantiated, and they are designed to be subclassed in general. We'll see that. They can contain abstract methods that must be implemented by, any class that would take the burden of saying, hey, I would like to implement this contract and start using it. Also, abstract classes, they provide template for other classes, ensure that there is a common interface, and they're trying to, reduce redundancy by sharing these template codes without having to share like exact implementations that change rapidly over time. Now let's think here hmm, of a good abstract class example. I want you to think of maybe a scenario where I have um, a shape class, and then I would like to draw a shape. Now you may ask, well, what shape is it? Is that a circle? Is that a rectangle? Um, or is it just a shape? And that's the point here. So in that case, the shape is abstract in its turn. So you define a shape class that's abstract. Uh, uh, um, and then you don't know an implementation yet. And then later on, someone will ask you to draw a circle. Now, this is when you say, right, well, I'm gonna go ahead and circle is a shape, so I'm going to go ahead and take that. Uh, uh, um, and I'm going to try to implement that contract of making sure that I'm drawing that shape, drawing this the circle of the shape, and I'm gonna implement that function or implement that method. So every shape that's implemented in our system has to contain the method that's called draw. And that's one way of enforcing certain structure in classes by saying, hey, anything that has to implement that shape or has to draw a shape, then pretty much will have to implement that abstract class. Now, the good news about it is that while it implements that abstract class, there are some functionality that maybe are already implemented. As I mentioned, abstract class could have few pieces that are implemented, few pieces that are abstract. So maybe I don't know how to draw a shape, but maybe at that point I know how to identify the XY Cartesian for the plane where the shape will be drawn. That's a general task that any shape pretty much will be, you can do it for any shape. So you can implement that at the shape class, and then it will be shared across all of the different classes, that try to implement that shape. So just keep that in mind. Uh, um, by using that concept, you can have some implemented methods. So some stuff can be actually, available. You can have the code here, and then maybe some others, will just be abstract. You won't have any implementation for them. And for those, whenever someone is interested in in implementing them, all you have to do, you can just implement that abstract class, try to take advantage of it. And as soon as you do that, you will get those free implementations for you because they're already implemented, and you can just address the ones that have not been implemented just yet. All right, now let's take that one step forward. So as I mentioned in abstract classes, the concept of abstract classes, you may have some implemented methods, and one or more methods can be abstract. I like abstracted methods. Now, there is a concept that's called the interface, and that's really when you're dealing with a system-to-system communication or a subsystem to a subsystem communication, you try to use what we call interfaces. And the interfaces, they are abstract classes, but they don't have any implemented methods. All of the methods that are existing in that interface are all abstract methods. They don't have any implementation. Now, unlike a programming language like Java, In fact, C++ and Python, they actually do not have an explicit implementation that you have to do in programming for interfaces. So you just have to implement it as an abstract class, and then from that, you just don't implement any method in that abstract class. And I will show that during the demo. So we're just talking about the demo, so it's time to jump to that. Now let's take a look at our example here. Now we have been talking and dealing with the book class, since the beginning of this course. Now let's talk here about a scenario, okay, where our book is considered to be a printable document. Now, for the printable document, we want to make sure that maybe we would like to create some sort of a structure or organize our code that anything that's going to be printable, that's going to be maybe communicating with external printers because they have to be printed. They need to have that kind of interface. They must have this kind of function because that's what's going to be printed, or sent to the printer to be printed on A4 pages. So in that case, you define, hey, this is going to be my interface. Any class that would like to send their information to the printer, they have to implement this interface. So you create a printable, and notice this I icon. This refers to interface because that means we don't have any implicit implementations here, and it's called printable, and it has one method that's called print details. It's not implemented, of course, and then the book would like to use that. So the only thing that book has to implement is to make sure that it has an implementation for print details if it would like to implement that printable concept. Now, few things here that I would like to note with respect to uh, uh, um, our demo. Um, the first one is related to when you look at the code, the printable here, and the fact that you are implementing this. When it comes to C++, interfaces, because they don't have any implementation, so you can just implement them using header files. And you don't need to create any CPP files, any C++ files for them. Now for Python, it's pretty much we don't have that separation of header and CPP file, so just mostly putting everything into a Python file at the end. But this gives an advantage for C++ that you're not gonna have to send all of the implementation over. It's just the header file, you send that over, and you even don't need a CPP, so they can use that to pretty much create their code on top of it. So let's go ahead and look into the code. So again, in our code base, you will see CPP examples. We have here abstraction, and we have so under CPP examples, you'll see abstraction, and you'll see similar folder as well under Python examples. Let's start with C++. So start with printable. Now, it starts with those includes at the top. If not defined for printable, go ahead and define it. That way, we'll ensure that we don't have multiple definitions and therefore the potential compilation issues. And then I'm defining this class that's called printable. Now notice there is really nothing that uniquely identifies this class, except for two things here. Well, let's start with the easy one. So this is called virtual void print details. So as you see here, there is something here that I added. It's called virtual. And it's const, so it's not gonna change anything in the attributes. But that concept of virtual, this is a qualifier, or a tag that you would add. You proceed it in your C++ method, and what it will do, it will make sure that any class that tries to implement this class or inherits it or try to use it in any way, they have to provide an implementation for the virtual method that you're seeing here. Like, let's see. So if we do book.h, now we're saying, hey, go ahead and do a public printable. Let me show you in the book.cpp. You will have to implement that. If you don't implement the virtual function, it's gonna give you an error because and notice here what we did. Uh, so here I did void print details const, and then I added this tag that says override. So it means that I am overriding this empty implementation, or no implementation that exists at the interface. I'm gonna be overriding it here in the book class because I'm trying to, you know, take advantage of being able to use the printable interface, and implement it. So do you see? That's really important here in C++ when when you're dealing with it. I think it's a code convention that if you in your header file of the class that is you're trying to implement that abstract, and by the way you're implementing it in a way that looks like it's inheritance. We'll talk about inheritance later. And you see here pretty much I'm doing void. This is the function, the method name, and I said, well, it's not going to change any attributes, and I added this tag here to say, hey, by the way, I'm implementing this virtual method or function that's existing in the printable header file, the printable interface. Okay, so that's the easy one. Now, by the way, we typically do this virtual void print details. I hope you get some information about that from reading the handout, or uh, um, from last lecture. So the virtual void print details const here, that pretty much it's a pure virtual function. It makes this like it makes this an abstract class, and by adding this also the virtual destructor, that will make it what we call an interface, because that means all of the methods that we have here are going to be virtual, which means that this by default became an interface. Okay, so now let's talk about what is a virtual destructor. The idea of virtual destructor here, you gotta have to make your specifically an interface or a super class, like a parent class that will be inherited. It's always advised that you make your class, you create a destructor and then you list it as virtual. So what that means, it means that without the virtual destructor in the base class, the destructor of a derived class will not be called if an object of the derived class is deleted through a pointer of the base class type. So it's more of there is a polymorphism game. If you have a pointer that's pretty much pointing to like this printable, but at the same time you have like the content of the object, uh, um, like you have another destructor of another class. Like I have a destructor here in printable, and I have I'm implementing this using the book, uh, um, um, the book class here. Now that book constructor here, or I'm sorry, the book destructor here, it will not, or there will be cases where it may not be called if I don't have a virtual destructor on that printable. So adding this virtual here, it actually really helps to make sure that your cleanup is complete, because it kind of lines up that your destructors uh, uh, um, are being properly called, and that your code is expecting that instead of just using a single destructor, it will make sure that it goes through all the chain of all of the classes that are implementing each other, or inheriting from each other, and it's executing the destructor of each subclass in the proper order. So just keep that in mind. Long story short, you need to add this virtual destructor here to make sure that your subclass virtual destructors, or the classes that are implementing your interface, their destructors are being called. That's long story short. All right. Now let's go ahead and see. Well, so here is the code. So here I created like a book, and then I'm printing the details. When I'm setting the title, then I'm printing the details. And there's really not much here. Actually, I don't think actually we need to run the code. I think the most important piece in this code, well, the number one piece in this code is how we are, defining here the concept of abstraction, how you can implement an abstract class or an interface in C++ using the virtual keyword in on one or more methods for abstract classes and all the methods for interfaces, and also making sure that you are adding a virtual destructor here in your parent class to or your interface or your abstract class to make sure that the destructors of your subclasses are are called properly. That's number one. Now, the second piece that I want to talk about is the concept of the concept of encapsulation. Now, as you see here, one of the things that we looked into is do we make we set the attributes as part of encapsulation to be either private or protected. Here are they. I set all of them to be protected. And then notice I created the setters and getters that pretty much can set and get those attribute values. So that would prevent publicly modifying those values from outside this class or any of its children classes. So let's take a look. So here are my attributes. Well, I defined them in the header file. So this I'm initializing them here. Okay, in the constructor. And then notice I'm using like book, get title, then I'm returning title. Now here, if I need to check maybe for set title, I can actually check if maybe the length of the title is greater than 0, then maybe it doesn't have like inappropriate words or things like that. I can apply all of that logic here. That's pretty much add filtration logic. And maybe like, it can be if else, and then if it passes our criteria, then, you will set the title, otherwise you can print an error. Similarly, for getting the author, setting the author, you can add all of these rules around the attributes that you're going to be setting or, be retrieving. So that's how you can implement encapsulation. Encapsulation is highly, highly advised for, whether you're doing it for the courses here or even for, your throughout your career in the job, or even if you're doing it also for like an academic research. That's really important. It's gonna help make sure that making sure that you are building a robust code that cannot be easily hacked. Now let's go ahead and just run this here quickly. So I'm going to do G++ dash O, and then I have book.cpp, bookshelf.cpp. Okay. Right. Well, I forgot to add bookshelf. Let me see. Uh-oh, looks like, did we lose the file? Yes, looks like we lost the file. Okay, here we go. Okay, we got it back. Interesting. I don't know what happened. Okay, so we just did it in the bookshelf, and here we go. So we got this, we got that. And it's only one book. So the total number of books is 1, and then we are destroying the books here. So all good. Now, if we look at the Python code, on the other hand, let me clear this. So now I want to note that pretty much in order to implement an abstract class or an interface in Python, you need to, have that class like inherit from a base class that's called ABC class. So that just defines it as like, hey, this is an abstract class. So you just do a printable, and then you would say it inherits from ABC. And then all the methods that you think they're going to be abstract, in our case, it's interface, so it's all the methods. You'll just have to annotate the method with @abstract method. Of course, don't forget the self, and then the implementation of the method will be just pass. Do not leave it empty. You'll have to put in pass, right? And then when you implement it, all you need to do is just do a book, and then, it will inherit from printable. And then that pretty much, in here, you will implement the print details. You don't need to add any annotations. You can, may see some books adding like add override methods or something. But if you don't add that annotation, it's fine as well. So print details, this is the the overridden method, and then this is pretty much how I'm gonna, print the details. Now we already know the static method. We talked about that last lecture. So the one that I want to talk about is the encapsulation part. Now in here, we have set all the attributes. Notice that the attributes now are preceded with underscore. Now, and by the way, that's we talked about the convention for setting or for naming the methods to have double underscores for private, single underscore for protected. Now for attributes, it's gonna be an underscore here. Um, so in that case, I am saying actually go ahead and use it for protected. So it's following the that same concept. And then notice what I'm doing. I'm setting a property, okay? And whenever I would like to set a getter, like retrieve the value, I will say it's add property. I will annotate the method, and the function itself will be the name of the attribute without the underscores. So in my case here, my attribute name is title. Okay, so it's a getter, so I don't need to pass in anything. It's I'm trying to grab the value or get the value. So I'm gonna add it here as add property, and then I will retrieve self dot underscore title. That would retrieve the title, like the current title attribute. If I would like to update it, on the other hand, again, it's the same function name, but you need to add this, this annotation here. It says add with your attribute name, okay, title.setter without the underscores, and then it's self.title, so it's self.underscore title equal title. And you would do pretty much the same thing for property. Like for author, you do the same thing. Property is a getter, and the author.setter is a setter. You do the same thing for years, for the year variable, and so on. And the way that you would use that is you would just book the print details. You will just call dot title. Now remember, your attribute name is underscore title. What you're actually calling in here when you're saying book one dot title is the setter and getter. Those are the ones that do not have underscores. So dot author, dot title, and dot year. And this is how you can pretty much either get values from them or set values to them. Now, if we see how we can implement this here, and you need to play with it a little more to be more comfortable with it. Let me see here. So Python bookshelf py, and here it is. Pretty much, this is what we're displaying here. For print details, we have, you're printing the title, then you're getting a new line, then author, then a new line, then year, and so on. And then this is this one is for the first book, and these results are for the second book, and this is the static variable. Oh, I'm sorry, it's not it's only one book. This one is for the first book. This is for the same book but with the updated title. Okay, and the total number of books is one, and then when the application ends and the main function execution ends, it runs the destroy function, which will pretty much run the underscore underscore delete, and it will print the destroying book object that you're seeing here, and decreasing the book count, of course. Okay, so that's really the main concept here. In Python it relies more on annotations, as you see. Uh, um, and making sure that your attribute names are preceded with underscores. That's how you can do encapsulation. And for abstracts, then you'll have to just make sure that you have your interface or abstract class is inheriting from the ABC class, and then you're marking any abstract methods with that abstract method, and then the implementation, the actual body of the method will be a pass. That's it. All right. Now, lastly, we can just, in order to identify the relationship between abstraction and encapsulation, think about encapsulation as it's about data hiding. It's about like restricting access. It's about increasing the security in your code. And it's about making sure uh, um, that you are reducing the risk of errors by limiting the number of points where you can update the attribute values. Now, on the other hand, abstraction is mostly about simplifying the complexity. So you're trying to hide the implementation complexity, and you're only trying to only show the necessary parts, so to make the development much easier. So you're not trying to do it for a security reason when it comes to abstraction, because technically you can have some methods at some point of time being partially implemented or fully implemented. But it's mostly about, hey, like I'm not gonna show you all the details here for this abstraction because, like, for example, you're trying to draw a shape. Well, I don't know how to draw, I don't know what shape you're talking about. So as we get more details, instead of trying to like write one big method that can draw every possible shape, just have multiple, classes, and have each class owns its draw method and draw its shape using its preferred way. But to summarize here, encapsulation will always help you achieve a better abstraction. Because if your data are being properly tracked, being properly restricted, you can have a proper restricted access, you can, implement a good hiding for the implementation of the complexity, and you can pretty much get a good control of what your users should see and what your users should have access to. So just keep in mind those differences between these two concepts and how they can be implemented in the code. What's coming next? We're going to talk about inheritance and compositions in the next video, and I can't wait to see you in the next video. Thank you, and we'll see you soon.